So, quick little review. How do you define an acid?
It donates a proton.
Okay. How do you define a base?
Accept.
Okay, whose theory is that?
Arrhenius.
Nope.
No. This is the hydrogen specifically.
Yeah.
Bronsted-Lowry model.
Bronsted-Lowry model. Okay. Emily, how do you define a strong acid? How do you know it's strong? Okay. What, Annie, would you say about the Ka value for a strong acid? It's huge, pretty much undefined. How about for a weak acid then? It's really small. Okay. What else? Grant, what's an amphoteric substance?
Well, but here's this acid or base.
That has the ability to behave as an acid or base. All right. Today. You guys remember these?
Yeah, I do.
Okay. There's a lot of them. If you remember, they're not like overly difficult problems. So basically, this and this are the inverses or opposites of each other. This and this are opposites of each other. Okay? This is how pH and pOH are related. And this is something you already have. This was your what? Your KW, your self-ionization of water. And most of our acids and bases that we're going to be doing are going to be done in water, so we can use the KW to figure out plenty of stuff. Now, you guys are familiar with log, I'm sure? Yes? You guys understand when you have log, if you want to get rid of log, you do the opposite, which is 10 to the power of that, because log is base 10. The pH scale is based on logs, and the reason why that is because that way you wouldn't be dealing with these massive numbers, okay, factors of 10. You can just deal with 1 through 14. With the occasional time where we get below 0, or the occasional time where we get above 14. Okay, I was going to talk a little bit about sig figs with logs. I'm not sure I really think it's that important. What was that? Don't do it. Well, I mean, the reason why I think it's important, but then I give you tests where you, I mean, very rarely do I give you two answers that are the same number, but one with just more significant digits than the other. Because I feel like if I did that, then you would know that's the one that is either one of the two, and you would just find which is sig figs and call it good.
Yeah.
So I can't really do that.
Totally do that. That's exactly what I would do.
Yeah, I can't really do that. So, all right. I'm gonna ignore it then. We kind of jumped the gun yesterday talking about the pH scales. Quickly, what does a pH of 7 tell you, Ben? Okay, what if it's 14, Daniel? Okay, and obviously below 7 it would be acidic. Okay, so if I have a pH of 10, Emily, do I have more hydroxide or more hydronia? Yep. If I have a pH of 15, then you know, more hydroxide, more hydronia. Hi, what? Nope. Did you just think I'd ask the other side of the question? That's why I intentionally basically asked the same question. Okay, so if you're basic, you're going to have more hydroxide. If you're acidic, you're going to have more hydronia. All right.
So the higher the pH, the less it is.
What was that?
The higher the pH, actually.
The less what?
pH.
Yes. Because as hydroxide goes up, hydronium goes down, and the opposite's true, because they react with each other. So like if I have a high concentration of OH minus, I'm gonna have very little hydroxide. Okay, and vice versa. So the reason why I say you have more hydroxide when you have a pH above 7 is because you have a low hydronium. Because technically, based on our equations here, we find pH based on how much hydronium we have. Does that make sense? But this is also dependent upon how much hydroxide you have. So it's really, we use the H plus to figure out pH, but it's also, I mean, you could have come up with a system that you could solve it based on hydroxide too. Okay? So, suppose you want me to do this, huh? I like just letting you do it. So, if you look up here, it says calculate pH and POH. Now you'll find that in these types of problems, you could actually solve these multiple ways. Like for example, if I have OH minus, okay, I could take this using the KW equation to find the H plus concentration. Does that make sense?
Yes.
I then could take the negative log to find pH. Or I could take this and go 10 to the power of that to get POH, and then what, subtract that to get your pH, or subtract that from 14 to get your pH. You could do a lot of different things to figure out and solve this problem. There's usually one way that's the quickest. Okay, so the reason why I would probably do 10 to this, 10 to the negative this to get POH, is because then all I have to do is subtract that from 14 to get my pH. Versus if you do the other way around, it's probably going to be one more step. So,
Oh. That's weird.
what's the matter?
When I did negative log, I got a different answer than the power.
Those two things are two different. I mean, what do you mean?
You said you can solve this different ways, right?
Yep.
So when I did it, just negative log, I got,
Negative log of this,
yeah,
that gives you POH.
yeah.
Okay.
Oh, I switched to still, when I did 10 to the power, I said negative of that, 10 to the negative,
That gives you POH.
yeah, I gave me different answers for the same number. Oh, I didn't have that.
Yeah, that gives you the concentration of.
Yeah, I plugged it in wrong.
Okay, so what I would probably do is find POH, 10 to the negative, wow, that's not true. I totally butchered that. I said that wrong.
It's
Yeah,
concentration equals.
I said that wrong. Yep, I'm sorry. That's why you got that wrong. I said that wrong.
Okay.
Yep, my bad. So what I would do is take negative, to get POH, I would go negative log of my hydroxide concentration. 1 times 10 to the negative 3. That should give you a POH of what? What'd you guys get? 3. Okay. Then pH is going to be 14 minus 3, which will give you 11. So there's your pH and your POH. Now that's one way of doing it. You can take this, convert the hydrogen ion concentration, then negative log of that to get pH, and then minus that from 14 to get POH. That would be one more step, probably.
Or can you just do the hydrogen ion?
The what of the what?
You do the, like,
Find the hydrogen?
yeah, so then you know it would be 11, because it's 1 times 10.
Sure.
And then just
Yeah,
subtract
there's a lot of ways you could do this. Yep. I mean, I'm looking at this. My guess is the negative log of 1 is
0.
Yep. So then that's why your pH is going to be 14.
Wait. Yeah, that's what's looking at.
So when you do negative log of 1.0, you get 0. So that's your pOH. So then your pH has to be 14, and it should make sense. That's a lot of base. It's going to be really basic. Do you guys get that?
So both these are basic, right?
What?
So both these were basic. Yeah, 14.
Appears so. Yeah, be careful. You cannot just look at the number of pOH without some thought to figure out if it's acidic or basic. So, like I couldn't just go, oh, pOH is 3, so it's acidic. Well, no. You have to look at your pH to determine that. Okay? So this one asks a little bit more. Wants pOH, H plus concentration, and OH minus concentration. It gives you what?
pH.
Gives you the pH.
7.41.
Again, there's a variety of ways for you to do this. This is the one where you can take 10 to the negative pH to get your H plus concentration. I totally butchered that a little while ago. What? You could use that.
Use that for the last one. the
Yeah.
minus.
Yep. Or you could use it, get it from your pOH. Does that make sense? You see how there's multiple ways to solve for this? That's why I'm not really think it's super great for me to show you this because I'd like you to be able to come up with what you feel is your best way of coming to this, because there's a variety of different angles and ways you can get the exact same answer. For example, with both of these information been given to me or that I've solved for, I could take this and find OH minus concentration, and I could take this and find the OH minus concentration. Does that make sense? What'd you guys get? 2.57. Okay. Well, they gave you really easy ones here.
Yeah. 1,
Yeah.
Go to power.
Yep. Well, actually, no. I do need to show you one of these. Because the second one isn't 10. So I need to introduce something that's really important here, which is this idea of what the major species are within an aqueous acid-base situation. Okay, so like if I had HNO3, okay, that's going to be in water. Okay, you get your hydronium plus your NO3 minus. Now, what do we know about this guy?
It's an oxyacid.
That's true, but more importantly, it's a strong acid. Now you guys gotta get yourself familiar with that. Strong acid means what?
pKa is off the charts.
Yeah, that's true. Can't spell completely.
It's TE. It's fine. Close enough.
Okay, completely dissociates, which means after the reaction has reached equilibrium, what are my dominant species here?
The products.
Okay? And I also probably could say H2O is my dominant species too. Why? Why do I say that?
It's relatively strong.
Well, usually you have a lot more water than any acid you put in.
Okay.
Does that make sense? So yes, we're reacting some of the water here, but usually you have a big beaker of water and you put a little bit of acid in. Okay, and if you look at the concentration, that's not a severely huge amount that you're adding. So your dominant species are these. Okay? So since your dominant species are these, you can just look at and figure out what your pH is based on this. Negative log of 0.1. What does that give you?
1.
Okay, so your pH is 1. I'm thinking, well, that I got that. Why did you show me all that? Well, I wanted to show you that because the next one is kind of tricky. We have HCl, still a what?
Strong acid.
Okay, still a strong acid. All right. And it gave us the concentration of HCl, which means that HCl is going to garner 1.0 times 10 to the negative 10 hydrogen ions. Right? If this completely dissociates, that's how many hydrogen ions it would give off. Does that make sense? Everybody? Okay? But here's the kicker. The self-ionization of water will give off more than that. Why do I say that? Right, we know it's 1 times 10 to the negative 14, right? And that would mean that the H plus and the OH minus concentration, this is so just water reacting with itself at equilibrium gives off a lot more hydrogen ions than this will, because there was so little of it that was put into water. So technically, the pH is not 10, 10, it's actually 7. For example, if I take 1 times 10 to the negative 7, somebody do that, and add 1 times 10 to the negative 10, what is your answer?
1 is 10 to negative 7. The negative 10 won't matter.
Yeah, it isn't going to matter. So adding this small amount or this little amount of strong acid is not going to change the pH from neutral. Okay, so this is really important for you to understand, because there's probably going to be a quiz or test question that they'll give you such a dilute amount of acid, and in our minds we're like, oh, strong acid. All I need to do is find the negative log of whatever the concentration of that strong acid is. Well, be careful, because if it's such a small amount that's added, it's not going to affect the fact that water already has a certain amount of it. And so just be careful. You might want to make yourself.
Big enough that it doesn't matter.
Yeah, this dissociates. This is going to give you 0.1 H plus concentration. So that would be like saying I had this to begin with, and then I add 0.1 to it. Now this is the negligible amount. Does that make sense? And this is the important amount. If I take and add that, that's not going to change this number much. Does that make sense? But when you have an acid that is so dilute, you gotta look to see if it's more dilute than the actual amount of hydrogen ions you're gonna get just from water reacting with itself. Okay, so I don't know, however you wanna do that, make just a little note that you always check if you have, for how dilute the acid is, because if it's more dilute than the amount of H plus that's gonna be given off or furnished just from water reacting with itself, it's easy to think, oh, because think about this. Why, this should hopefully make logical sense. I added an acid. Why would my pH be basic? Does that make sense? Like if you took the negative log of this, you would get a pH of 10. You know what I'm saying? Everybody? Does it make logical sense for me to add an acid and get a pH that is basic?
Oh, it's right favored. It kind of makes sense if that's a strong conjugate acid or conjugate base group.
But this is a strong acid.
Okay.
So it's going to completely dissociate. It's going to be far right.
Look at that for strong acids? Or just whenever the pH is below.
What I would look at is anytime you have a concentration of strong or weak acid that's way less than 1 times 10 to the negative 7, assume that the pH is neutral. Because it's not going to affect.
So
And-
pH is just 1 times 10 to the negative 7.
Well, pH is 7,
That's a ten.
but it comes from this.
How do you even measure something that small? I guess I'm assuming it's 1 liter. You could have like 20 liters. and
Yeah,
it's a single element.
Yeah, I don't. Okay, does that make sense? It's really important to make that distinction that it doesn't make logical sense for me to add acid to something and get a basic solution when I'm adding it to water, which is already neutral. We're done.